Oh, hi there! My name is Enrique and these are my partners, Luismael López and Rosario. Under the advisory of Professor Rafael Rodríguez Solís, we are embarking on a project to characterize substrate integrated waveguide structures, or SIW structures, and their use in millimeter wave antennas.
SIW structures have become a common way of designing microwave and millimeter wave circuits and antennas, thanks to their compact size and ease of fabrication.
However, although many works have pre-described filters, resonators, transitions, and antennas, few authors have described the operation of the SIW structures or provided a characterization to determine their propagation characteristics based on the design parameters and substrate characteristics.
We would like to be able to know the effect of the SIW's design parameters on their characteristic impedance, the guided wavelength, wave velocity, and losses.
Therefore, our main goal is to generate SIW design information for circuits and antennas at millimeter wave frequencies.
Our group is focused on characterizing the SIW structures and then performing a preliminary design of an antenna which will be selected based on the results of the simulations of the varying parameters.
After reviewing literature to find design guidelines for the waveguides, we'll be utilizing ANSY's HFSS to simulate the SIW structures to determine the effect changes in pin size, pin separation, SIW width and height, and substrate permittivity, and the waveguide performance.
These are the parameters in 3D model: pin size, pin separation, width, height, and permittivity, all of which will be evaluated and changed to be able to characterize their effect in performance of the waveguide.
The group will be modeling in HFSS SIW structures at 30 GHz, each student changing the specific aspects of the parameters to be able to keep the workload evenly distributed and have every student learn about modeling and simulating in HFSS. After 2 weeks of modeling, the team will sit down and analyze the data to be able to characterize the structures and be able to select one antenna structure to design and build.
After performing preliminary design, modeling, and simulation of that selected SIW in HFSS, the results will be organized and presented in IAP meetings and the final report to the end users. As students, we will learn the value and importance of electromagnetic computer-aided design software and the theoretical foundation for the numerical methods used in them.
We will also become familiar with antenna systems and the advantages and the disadvantages of different waveguide structures, while having the opportunity to develop our ability to work in teams, give our presentations, and write papers in accordance with IAP and IEEE standards.
Project success will be measured by the level of understanding we obtain in waveguide operation performance and the use of electromagnetic simulators, which is of utmost importance in the industry, also by the development of the design guidelines for SIW and the design of the antenna, using the guidelines developed and the results of the characterization.
The project itself has a budget of $1,500, which is requested for substrate materials and prototype fabrication of the selected antenna structure.
Any further questions or inquiries might be forwarded to the advisor, Professor Rafael Rodríguez Solís, for consideration.
Thank you for watching this video, and we look forward to be presenting the progress of the group in the months to come.